The most successful scientists can tell a great story.
Science is messy and complicated and hard and human.
Trying to bring some empathy into these scientific discussions.
There are all sorts of psychological effects of narrative.
There's a story going on there. In fact, there's usually a whole set of stories.
I think storytelling is hugely underrated but massively important part of science.
How are we going to tell a story with this data?
Hang on, this wasn't the scientific fairy tale I was told.
Hello, and welcome to my new podcast, the Storyology Podcast. I'm your host, Anna Ploszajski, and in this series, I'm investigating what's going on when science meets story. I'll explain. It all started about 10 years ago during my PhD in materials science, and I was researching hydrogen storage materials. I would go home to my friends and family and talk to them about my work, and their response was either, isn't hydrogen really dangerous or isn't it really explosive? What about the Hindenburg disaster? Or are you just building bombs? This was a far cry from the reality of my work, which was about developing new green energy technologies. So this got me really interested in public engagement because I thought there was no point in me just developing my technology on the lab bench if it was never going to be able to make it out into the real world to be accepted by society and become useful for society. So for me, it all started out with stand-up comedy. I started doing comedy routines about hydrogen storage materials, and it may not come as a surprise that I soon ran out of one-liner jokes about hydrogen storage materials and turned to wanting to tell stories about my life as a scientist and all of the different weird and wacky adventures that it had taken me on. I devoured books by novelists and screenwriters and watched all the YouTube videos that I could find about how to tell a good story. And what I found was that there was quite a simple set of rules that I could follow surrounding world building, character building, how to build dramatic tension and generate curiosity in an audience, how to achieve narrative flow. And by applying these techniques to my comedy writing, I found that my writing was much quicker. It gave me a clear structure to follow. And it was helping me to engage with audiences with this technical science stuff at a much more human level. As my PhD went on, I also started applying these techniques to my scientific life, writing up my PhD thesis as a story, finding the drama in the literature review, writing papers and presentations as stories as well, and winning lots and lots of prizes along the way. I basically became a bit obsessed with the promise of story and how it could be used in science. So fast forward a few years, and 3 years ago, I threw in my academic career to start a full-time business teaching storytelling to scientists. And for a while, the business went great. I was teaching scientists to write better and present better, both to each other and also to the wider public as well. But the more time I spent at this intersecting space between the worlds of storytelling and science, the more I began to realize that just teaching researchers to give better presentations was actually only scratching the surface of how these two powers intersect. Stories influence how we, the public, understand science, but also how the scientists themselves analyze and do that research. And stories can even influence what science gets done in the first place. We often think of science as being this sort of bastion of objectivity, but what I found was that the more I learned about storytelling in the world of science, the more I could see that stories' subjective influence was creeping in. And the question that I'm interested in is, what does this mean for us in society? Every time we take advice from our GP or decide what to eat for dinner or buy dog poo bags or vote, science and story are right there influencing our choices. If we're to make sense of this complicated modern world that we've built for ourselves, I think it's imperative that we understand evidence properly and understand the influence that science and storytelling are having on our decision making. And that is what this podcast is about, the effects, risks, limitations, and opportunity of what happens when science meets storytelling. In this first episode, we're going to hear from two experts who have spent their illustrious careers at this very intersection. Baroness Alex Freeman has made documentaries mostly for the BBC and then went on to work at Cambridge, where she studied evidence communication. And that was where she got interested in the downsides of using storytelling in science communication. And Professor Marcus Munafò is a university professor in psychology and health behaviours and Associate Pro-Vice Chancellor for Research Culture at the University of Bristol. I started our conversation by asking them both, what was it that first got them interested in this intersection between story and science?
Well, I mean, my whole career was kicked off by some of the great storytellers. So, as a child, I used to watch David Attenborough documentaries, and I remember, that feeling of where's the story going to go? And he would leave you on a cliffhanger for the next episode. And then reading writers like Gerald Durrell, who would bring humor in. And these were great page turners that got people interested in science. And I'm sure I'm not the only one of my generation who came in through that kind of storytelling. And I always wanted to do that kind of thing. So I went to the BBC and I wanted to tell stories and engage people and make things interesting and fun, but with a scientific basis. But then when I went to Cambridge and started looking at evidence communication, and evidence communication is communicating scientific evidence in a way that helps other people make a decision based on it. And I heard people that I was working with, academics, talking about how are we going to tell a story with this data? And the way they were writing papers to communicate science and their findings to other researchers, they were talking in exactly the same way as we'd been talking within the media, which is essentially an entertainment industry, about how to get more readers and how to tell a story with what they'd found. And it really started troubling me that the sort of pressures to tell a story and to bring readers in was actually potentially influencing the way people not only looked at the information that they had from their research, but even what research they were doing in the first place, because they had an eye to what stories they wanted to tell. And it worried me that science itself might be being influenced by looking ahead to how you wanted to communicate that and what you would get out of communicating that. So the incentives that researchers are under.
Okay, so even from the point that they conceptualize the research that they might want to do before they've done it, they're looking ahead and thinking, how will this be received or how can we sell it?
Yeah, I mean, within my research group, that wasn't the case, but I went to a conference where there was this great speaker who'd been brought in, who was the kind of, cover of Time magazine type scientist. And they were giving a talk to early career researchers about how to be successful within science. And they started out by saying, the first thing to do is think about the headlines that you want to achieve.
Wow.
And then start thinking, what research you need to be doing to get those headlines. And I literally thought that they were going to say, of course, I'm joking. This is the worst thing you can do for science. And they didn't. The whole of the talk carried on about how to, choose the subject, think about the headlines, and then work towards it. And I just thought, wow, this is a world that we shouldn't be in.
Yeah, and we're going to dig a bit deeper into the outcomes or the kind of unintended consequences of those sorts of approaches in a minute. But Marcus, how about you? What was it that got you interested in this?
So my journey was slightly different. As a PhD student, I was just starting out doing experiments and decided to try to replicate a study that had been published, a finding that had been published, and I wasn't able to. The experiment didn't work, and I emphasize that to sort of put it in quotation marks. And my reaction was the natural reaction of a first-year PhD student, which was to think, well, obviously I'm not cut out for this. I must have done something wrong. I haven't got the right skills, whatever. And it was only because I was lucky enough to have an encounter with a senior academic who said, actually, no one can replicate that finding. It's rubbish. Everyone knows that it's flaky. And that was the first point at which I realized that the way in which science actually worked was not the way in which we were taught that it would work in terms of the hypothetico-deductive cycle and falsification and all of that kind of stuff. And throughout my career, there were more and more instances where these little moments occurred that made me realize that how science actually works is not how we're taught it works. And that piqued my interest. I thought that in itself was interesting. And I realized that that was an area of study in itself. And in 2005, Johnny Anides published a now quite famous paper, Why Most Published Research Findings Were False. And that was powerful for me because it made me realize, actually, I wasn't the only person thinking this stuff, and other people were looking at it. And there really was an issue here that we needed to address. And so I became interested in the wider factors that influence how science is done, and in particular, how we can ensure the quality of the science of the research that we do. And I started to have similar concerns to the ones that Alex has articulated, that it was too much about publishing for the sake of getting published, that we were incentivized to publish rather than to get the right answer, that no one ever gave a full and transparent account of everything that was done and all of the messy findings as well as the elegant ones. So there was this impression in the literature of this incredibly seamless, elegant progression of knowledge that was wildly removed from the reality on the ground. I can give a personal example, which is that we submitted a paper to a journal which included, I think, 3 experiments that we'd done, and they didn't actually all hang together terribly well. The results were a little bit conflicting, and one of the figures, one of the findings stood out as inconsistent with the others. And that's just how science works. You know, there's a certain amount of randomness. You're dealing with noisy biological or behavioral data. There will be flashes in the pan that may or may not mean anything, and it's difficult actually to get your handle on what's really going on. One of the reviewers that was looking at this when it was out for review at the journal came back to us and said, "This is all great, but you should remove figure 2. You should remove this finding because it spoils the thread, it spoils the narrative." And I thought that was really striking because on the one hand, we had been really transparent and reported everything that we'd done, and we're trying to make the best sense of it that we could. But the reviewers at the journal were saying, this is basically spoiling the story. It's making it too messy, too complicated. We want a cleaner narrative. And the fact that that had become so kind of baked into how we work that even reviewers were suggesting that to us, I thought was really striking.
Yeah, and this extends far beyond psychology as well, doesn't it? It's not just the sort of biological or psychological data that you look at, Marcus. It's a problem across the board.
Yeah, I think that's right. I mean, Alex has come from a very different perspective and has probably seen more disciplines than I have. But I've worked across a range of sort of biomedical and life sciences disciplines, and there's nothing particularly unique about any one of them. And I can understand, this is, I guess, where the tension comes from. We want to write clearly. We want to be able to communicate what we found. And sometimes that's difficult when you have messy findings. But I don't think we should go too far in the direction of just cleaning up the narrative at the expense of the reality of what we found.
Because at each stage you're kind of losing data, right? So that when the story reaches people in Alex's world, in the media world, they've already been given a narrative version that is already different from what really happened. And then I suppose there's an incentive to put a narrative spin again on it. Is there, Alex?
Yes, there is. And I think journalists often get unfairly blamed by academics for the, sexing up the science or streamlining the narratives and making it simpler and dumbing it down. Yeah. But actually, that is something that starts way back. It starts with the research that's done, then it happens at the point of publishing the paper, as Marcus was saying, and then the press officers, and then the journalists. And if you think about it, people who are in the media, they are creating entertainment. And we can have a big different discussion on a different podcast about whether news should be part of entertainment. But essentially, you are being you're being paid to make things that people want to read. Yeah. Whilst scientists are not being paid to make things that people want to read. So there are 2 different worlds, and they need to have 2 different incentive structures. But I think there's probably been a move towards ensuring that research that's done is useful, and that's turned into a kind of impactful agenda. So scientists are often told, impact is really important. And in a way it is, because the point of doing research is to advance our knowledge, and to advance our knowledge to help us make better decisions or better informed decisions. But looking for impact, and if you're measuring impact through measures of popularity, then that means that you end up doing work with an eye to popularity. And popularity comes through things like people clicking on things and people, listening and watching things. And that drives through the need for greater entertainment and engagement. And that, I think it's just dangerous to set that as our only end point and our main end point, really, for research, because it's not there to generate entertainment. It's there for something else. And we need to be able to measure the something else in order to incentivize researchers to do that something else.
So what are the risks then, as it currently stands, as we've identified these problems and how the system is currently operating? Why should listeners care? Why should people outside of the world of science care about these narratives?
I think that as society, we really need to be able to rely on our research base and our understanding of the world, because it underlies so many important decisions. So decisions that you as an individual might make about healthcare or choices in finance and choices in education, all of that is predicated on understanding cause and effect. So if I choose something, if I do something, what is likely to occur as a result of that? And that is essentially what science is doing, is understanding cause and effect relationships in a way that helps you build decision-making around it. And if that evidence base, if that knowledge is being essentially contaminated or is not robust in some way, then I think that undermines our ability to make decisions. And so I think it's really important for all of us and for society in general to be able to rely on that research base, because that's what it's there for. It's there for us. And it's not just there to create entertainment and clickbait.
And I think there's another angle to that. So when research is published, it becomes what's known as the version of record. So it is a record of what was done and what was found. And most of what was done was funded by public money through research grants from government funders that are funded through the public purse, from charitable donations. So without wishing to get too moralistic about it, I guess, it's a serious business. This is something where academics are entrusted with public money to do research and given a huge amount of freedom to pursue their own personal interests, as well as the avenues of research that might benefit society. And that's an enormous privilege. But with that, I think, comes a degree of responsibility to make sure that we are doing this well, doing this in the right way, that we are making sure that what we put into the version of record is a full, transparent, honest account of what was done and what was found, and not embellished or finessed in a way that is intended to accrue citations or clicks, for example. And the problem arises because of some of the incentive structures that currently exist, that we are incentivized to get our work cited, to get our work out into the media and so on. And arguably that's gone a little bit too far because it's having this distorting influence.
So maybe let's take a concrete example. So let's say I go to the GP because I'm concerned about something around my health. The GP, their job is to, hold a degree of scientific knowledge in them, in their own heads, but then also to have the ability and the knowledge of how to search the literature in order to find a potential solution for me, right? That's a bit of a diluted version, but that's generally how they would sort of operate. So when they're then digging into the literature and thinking, okay, how am I going to solve Anna's problem? How might this sort of distorted version of research impact how they interpret the literature and then what they relay to me?
So I can give one example, and I'd be interested, Alex may have others, but we did a study a little while ago looking at randomized control trials of antidepressants. And these are trials that tell you whether or not an antidepressant works or not, basically. And so that's the kind of foundational evidence that practicing clinicians use when deciding whether or not to prescribe drugs. It's the evidence that's used by regulators to decide whether or not to license a drug and so on, to make it available on the NHS, for example.
Yeah.
And the good thing about this is that it's a heavily regulated space. And so companies that are running a trial of their new drug have to register the fact that the trial exists and what their primary outcome is with the FDA in the United States, which is the regulator in the United States, the Food and Drugs Administration. And they also eventually need to submit their data there. So that's all really good. And it means that you know the ground truth. You know what really was done, what the primary outcome was, what was found. And when we look at those trials, we find that about half show a benefit for the antidepressant over the placebo, and about half don't. And that's what you'd expect, because clinical trials are meant to be in what's known as equipoise. So basically, we don't know what the answer is. If we did know what the answer is, it wouldn't be ethical to do the trial.
Yeah.
So it's a toss-up. We do the trial, we find the answer. So that's all really good. But then you look at the published literature, and that's where the distortion comes in. So this is information that's held on the FDA website. It's publicly accessible, but not in a version that anyone would want to read. And then there's an incentive for the companies to publish their results so that clinicians, for example, can read the findings. And instantly bias starts to occur. And we showed that there are several biases that creep in. First of all, publication bias, so whether or not you write up the results in the first place. And about half of the studies that didn't show a benefit of the antidepressant never got published. And all of those that did show a benefit did get published. So instantly, only 3/4 of the findings are actually getting out into the published literature anyway. And then you have outcome switching, where you get a stronger outcome for or a stronger result for a secondary outcome. So you pretend in your write-up that that's the primary outcome, or you place greater emphasis on that. And that's typically in those studies that didn't show a benefit of the antidepressant, so you can nudge the findings to look more positive. Then you can put a little bit of what's known as spin on the findings. So those results that were a little bit marginal, you can big them up slightly. And so you have this cascade of effects. And what you end up with is a wildly distorted impression relative to what the ground truth actually is.
That's fascinating. And so then it would be the clinician's job to be able to critically read and sort of read between the lines almost in order to be able to make a recommendation.
Exactly. But of course, that's really hard work, because they're busy people who shouldn't have to do that. And they'd have to know that they have to do that. It's not really about critical appraisal in the sense of, oh, I might have done that study slightly differently. It's about knowing that what you see in front of you has been distorted via these different steps, via this cascade, relative to what the ground truth is.
And that's a very specialist skill that doctors, that's not part of their training. They don't run clinical trials, so they don't know all of this underlying stuff, just as, the rest of us don't. And I'd say on top of that, there are also psychological biases that all of us have. So we want things to make a difference. We want to be able to make a difference to somebody's depression. So we want to be able to give them something that helps. And as patients, we want to be able to take a treatment that'll help us. So there's biases that lead us towards wanting to take treatments as well. And I think that also can be fed by narratives, and the narratives of success of science and medical treatments having benefits. And if we don't hear much about the potential harms of medical benefits, then I think we're much more likely to want to keep taking them, because we hear about, well, it might make a difference, I'll try it. We don't hear about, well, the downsides of that are this and that. So I think we end up with sort of stories in our heads that lead us down paths that we wouldn't necessarily go down if we didn't think like that.
I think, first of all, I think it's important to say that a lot of this is not malicious on the part of academics. I think there are some cases of drug companies finessing the literature because they have a financial vested interest in doing so, in terms of returning on the investment it's taken to get a drug to a certain point. But that's a relatively small part of what we're talking about. The vast majority of academics or academic researchers are motivated to discover stuff, interested in their subject area, really passionate about what they're doing. But that's a double-edged sword, because all of that can lead you to see patterns in your data that don't exist. We can easily fool ourselves. We're all human. We're all invested in what we do. So confirmation bias can play a part. And I think the problem arises in part from human fallibility and a lack of protections against the kind of biases that we bring to our own work, and the lens that we see our own data through, for example, which is ironically something that I think is much better understood by arts and humanities researchers than, say, biomedical researchers. And also the incentive structures that we work within, the incentives to publish, to garner citations, to get our work into the media and so on. All of those are not inherently bad things, but can be problematic if we don't protect ourselves against the extremes, if you like. But I think it's really important to point out that I hope very little of what we're talking about is actually consciously malicious behavior. But I think also part of the reason it's so widespread is exactly because in a lot of cases, academic research doesn't matter in the short term, at least. We do a lot of discovery research. We do a lot of curiosity-led research. That's what makes academia relative to, industry, for example. And that's really important and really valuable. And who knows where that scholarly knowledge might lead us. It enriches society in all sorts of ways and may have downstream impacts that we're not yet aware of. So we don't want to lose that. But exactly because it doesn't matter, no one dies, no bridges fall down in the vast majority of cases, no one is really checking this stuff as carefully as it might do. And there is a cost in terms of public money, in terms of opportunity cost, in terms of other things that we could be doing with our time as academics, in terms of early career researchers thinking, as I did, that they're not cut out for a career in academia because of their own experiences, because they don't see the reality. So I think there are lots of hidden costs that actually are important, even if there aren't immediately obvious public costs, if you like.
Hello, Anna here. Just jumping in around the halfway point to recap what we've learned so far. So we've heard that researchers are under immense pressure to publish their work. And to do this, they're expected to tell a good story, not just present their evidence. In some cases, we've heard that this means that they're being encouraged to omit some of what was done or to spin a narrative that sells the work in a certain light. We've even heard that researchers are being told to decide what story they want to tell before they've even done the experiments and know what they're telling. And this is very far from the supposed objective scientific method. I think that perhaps one of the impacts of this is what Marcus was describing in this reproducibility crisis. The fact that science is getting published on flimsy grounds and it can't be replicated by others. It seems to me that in the modern world that we live in now, the success of even scientific research is being measured by clicks and likes over the quality itself. Now, you might be saying, yes, but Anna, haven't you built a business on training scientists to be better storytellers? Yes, I have. Maybe I'm part of the problem, but in my mind, good storytelling is never about oversimplifying or losing this precious, messy data. Some of the greatest stories of all time are incredibly complicated and messy and non-linear. I don't think that the problem is the approach of storytelling itself. I think it is more maybe the motivations and the incentive structures that exist in science that is causing this temptation to deviate too far from the truth. And those different ways of telling stories is a thread that Alex picks up on next.
I'm interested in the effects of narrative and other ways of communicating, because I think we as humans are very much storytellers. We love stories, we love narrative, and that is our instinctive way to communicate. But I'm really interested in the ways that can be very persuasive. It can create suspension of disbelief. There are all sorts of psychological effects of narrative, which I think make it a real double-edged sword if you're using it for factual communication, because we know from experiments that it can help people remember information, they're more engaged with it, but that it can make it more persuasive. And I'm not sure why it makes it more persuasive, but I think quite often you expect a narrative to have an end point and you are following characters to that end point, and there's a cause and effect baked into narrative that I think is probably a property of narrative itself. I think if you think about narratives where the characters and the protagonist's actions aren't affecting what happens, you end up with very interesting storytelling techniques like Kafka or something like that, which is not the norm. It's breaking the norm. So I think the norm is expecting cause and effect and a kind of stepwise progression. And I think that tends to lead people to certain conclusions. So I think there is something probably inherent about narrative structure that makes it more persuasive. And if you want to give people information but leave the ending opening so that they can make their own decisions based on it, and or that it's a complicated situation as research often is, with uncertainties and no firm conclusions. I think people, or we, are often set up to expect a narrative structure and not expect a more open-ended structure. So I think there's really interesting different ways to set up how we're about to communicate if we're not going to tell a nice, simple, archetypal narrative. And when we communicate to people to help them make decisions, so like presenting evidence to patients or presenting evidence to policymakers, we often find that people are initially thrown by it because they're expecting what we're giving them to tell them the answers, to say, here is information, just take it away and do what you're told. And if they're left with an open-ended decision at the end, they find that unsatisfying if it's not fulfilling their expectation. And I think this is probably true of us when we go to the cinema as well. If you are expecting a nice conclusion, is it going to be a comedy or a tragedy, a happily ever after or a disaster at the end? You know that there's going to be an ending and you're expecting it. When you come to the end of a film and it doesn't conclude and you're left open, if the story wasn't structured such that in itself is expected and feels satisfying, then you can come away feeling, I didn't like that film, I didn't like that.
Yes.
The ending wasn't fulfilling.
That narrative expectation is so interesting.
Exactly. So I think what we've learned to do when we're communicating in this way that is to inform and not persuade is to make it very clear up top that that's what you're going to get, that this information is to support you making your own decision. We are not going to tell you what to do. And so I think there's a lot we can do when we're communicating evidence to just set the audience's expectations that this is not a simple narrative. This is a different kind of communication. And then they can feel very satisfied because they're getting what they expected.
Right. Okay.
So I think as scientists communicating, sort of setting up at the top is very important. And I think we need to explore different ways of communicating information.
Yeah, and managing those expectations. Do you think an element of it is cultural? The archetypal story arc that has a happily ever after is quite, from the reading that I've done, is quite a kind of Western archetype. I know that there are other cultures, particularly from the Far East, sort of Japanese storytelling, Korean storytelling, Chinese storytelling, that expectation isn't there. Where readers in those cultures don't expect to be given the answer, don't expect to have everything resolved and tied up neatly, which is part of that tradition, that those stories stay with you and you remain thinking about the characters and where the ending might have been. Alex, do you think that there is a cultural element to the narrative expectation?
I do, and I'm not an expert on cross-cultural narratives, but I think that certainly in the last decade, with increasing amounts of storytelling within video games, for instance, and those more narratives that are so cleverly designed to be open-ended and to allow you to make decisions within them. And again, the big box set where we expect a really complicated narrative with multiple protagonist pathways. I think culturally, even within the West, we've become much more open to different types of storytelling. And I think it'd be really interesting to explore that and to capitalize on that, to be able to tell more complex and more open-ended narratives within science.
What do you think that would look like, Marcus?
Well, I think that's a really interesting challenge, to be honest, and I'm not sure what it would look like. I think what's interesting is also the extent to which that kind of closed loop narrative is baked into the structure that we expect in research papers. So again, in biomedical sciences, we're taught to write an introduction, our methods, our results, and our conclusion. And sometimes it's called conclusion, sometimes it's called discussion. the word conclusion is interesting, I think, in this context, because it sort of implies that we're going to wrap things up neatly, and this will be a nugget of knowledge that something has been found and is known. And of course, science is much more uncertain than that. There's no single definitive study. Everything is not just incremental, but mutually supporting. And we build knowledge by things leaning on each other, if you like. So no single paper is ever going to give the definitive answer, or very rarely, at least. But there's something about the way that we structure the writing and the word that we use to describe that final section that could lead us into thinking that it's meant to be. And I think that's part of what has evolved over time, because, you know, you could just be concluding the best you can from what you've done and what you've found, and it's a bit messy. But I think, and I don't know if it's changed over time. I think that would be an interesting thing to look at. I've not done so myself, others may have done. The extent to which, the degree to which a research paper draws firm conclusions on the back of what is reported, as opposed to preliminary conclusions or open-ended questions, future directions, and so on. The extent to which that's changed over time, I don't know. But certainly now there is a tendency to wrap papers up and say, we have found, you know, this, with some notional nod to limitations and future directions. But that's always, you know, it often reads as a bit of an afterthought.
Yeah. Yeah. When I'm teaching researchers to kind of resolve their story, if you like, the main thing I say is that it's fine for it to be open-ended, but you have to at least, for a satisfying resolution, you have to at least refer back to the question that you were trying to answer. Even if when you do that, all you can say is, we still don't know, or we've answered this partially, that can still feel satisfying without it having to be, you know, 100% answered. But I suppose maybe that's not how we're being trained to leave our readers.
And I think we overly prioritize confirmatory research, and we often try and crowbar what actually is exploratory research into a confirmatory research mold and therefore narrative. You know, a lot of sciences, particularly the physical sciences, their history is really just measuring stuff ever more precisely and only getting to the hypothesis testing bit quite far down the line after sort of several hundred years of that. And a lot of biomedical and life sciences are trying to fast track to the hypothesis testing bit, and maybe aren't dwelling enough on the hypothesis generating part where you just look at stuff, measure stuff, prod things and see what happens and go, oh, that's interesting, which actually is how science works on the ground in reality. But when it comes to what we write up and put it into the version of record, it looks rather different.
And I suspect that comes down to how people are incentivized, but also because your ideas of what makes good science is to an extent shaped by what you see in the media. So you see, you know, conclusions and conclusive sounding research reported in the media, and you don't realize from the outside that underneath that is a vast amount of research that is observational and you know, introductory and preliminary and in the lab, and is never going to be reported in the news. And not everything, very little of what is done as research should end up as a news story, because it's, you know, if it's a news story, it's you're telling people something because it is now at a stage in which it might influence their lives and be of importance to them. And that, as Marcus says, only comes after hundreds of years of being able to measure things carefully and poking things and seeing what happens.
I'm going to let you both go in a minute, but I want to finish our conversation by asking if you have any tips or advice for me as I set out on this quest and go and talk to researchers, go and talk to journalists and journal editors and grant holders. What should I be thinking of? What should I be looking out for?
I would be surprised if anyone has had a wildly different experience to what we've described. When I talk about these things with people, there's generally lots of sort of nodding of heads and an agreement that, you know, these things are issues and that they exist. But then everyone feels a little bit hopeless because, well, this is the system and, you know, we can't change it individually. So I think it will be interesting to find out what people think could be changed and how we could feel more in control of a system that ultimately is all just us. You know, this is all academics doing this to themselves in terms of what we expect to see published and, you know, what we incentivize and so on. So actually, in principle, we should be able to change this. But in reality, of course, these things with a long history in particular have enormous inertia, and we feel a little bit helpless against that. But if we could come together and coordinate what we're doing a little bit and be a little bit more innovative and bold in our thinking, perhaps, then maybe we could change things.
I would love to hear from experts in narrative about their ideas of why storytelling affects us the way we do, the way it does, and whether we can learn anything from people who write narrative in different ways to make our storytelling about science much closer to the way that science really is, so that we can better communicate the reality of scientific research. And I would also love to hear from people who rely on our science, so policymakers and clinicians and engineers and economists, about what they really want to hear about and how they would like to hear it. So are there ways that we're not communicating that they would find much more useful ways of communicating?
Well, there you have it. I think I came away from this conversation reassured, actually, that this is absolutely a thread worth pulling on. There is a real impact of storytelling on science, and we've heard some of the negative side of that when it tips over into persuasion and entertainment over simply informing audiences. But this second half of the conversation also makes me believe that there are potentially real opportunities here. Narrative, we know, can help people to make sense of complicated ideas, but I think what we need to be careful of is that scientists understand the implications of using it, understand how they're setting up expectations in their audience, or perhaps even leaving certain audiences who are used to hearing different types of stories a bit cold. And I think maybe we as the audience members need to be more aware of our own narrative expectations of science. Are we also pressurizing scientists to come along and save the world and be the heroes? Could we maybe be a bit more accepting of failure and ambiguity in this process? I hope that this conversation has piqued your interest in this intersection between story and science, and that you'll join me now in my investigation to understand just what is going on here. My plan is to track the presence of story throughout the process of how science gets done. So we're going to start with the very beginning, how science gets funded in the first place. How does story influence who's getting the money, how they're persuading the people with money to give it to them to fund their ideas? I'm going to talk to researchers as well about how they feel about the process of getting their ideas funded, and also how they more broadly use storytelling to convey their ideas to each other in writing and publishing papers, as we've talked about in this conversation. I'm going to talk to the publishers as well to hear it from their side. How aware are they of the techniques of storytelling being used and these sort of different narratives that are at play? And then we're going to be tracking the pipeline of how science gets disseminated to the public. So from those scientific papers, they're then picked up by science journalists, and I want to talk to them about the awareness that they have around the stories that they're reading and the stories that they're telling. Then I'm going to talk to the people that take the science that is out there in the media and create more content with it, the science entertainers, the content creators, the presenters, the documentary makers, the people who are generating stuff for public consumption. And finally, I'm going to end with society itself, the general public, the ultimate consumers of these science stories, and try and understand how aware they are, what do they feel about what's going on when they are hearing and consuming these science stories. I'm hoping that this series is going to be an investigation into the extent of the influence of story in science. And along the way, I hope that we'll find out some tips of how we can maintain trust in this flawed system of science, and how we can learn to read between the lines of the science stories that we hear, so that ultimately the most important thing is that we can make better informed, evidence-based decisions about our own lives. Personally, I use non-biodegradable poo bags, by the way, and we can talk much more about that if you're interested in future episodes. This podcast is made in partnership with the UK Reproducibility Network, Sonic Screen Lab at the University of the Arts London, and StoryArcs at Bath Spa University. StoryArcs is an Arts and Humanities Research Council funded programme. I've been your host, Anna Ploszajski, and if you want to read more about me and my work around science and story, you can head over to the Storyology website at storyology.co.uk. Thanks for listening, and see you next time.